So I'm going to put their common ratio, aka constant ratio. And the constant ratio has a specific formula to determine it. Okay, and how do you get this? Well, the test, this is really the test to see, test for a geometric sequence. This is really the test for a geometric sequence. And what is the test? It is to test for the ratio. To test if T3 divided by T2 gives you the same thing as T2 divided by T1. Or Tn over Tn minus 1 or Tn plus 1 divided by Tn. Right? This just says take the term to the left, to the right. So really this is the test. Now for the future examples where we're going to continue now, I'm going to do this test example with you guys, right? So we're going to use the same sequence and we're going to see how to find the common ratio, even though we already know the common ratio. So let's do 2, 8, and 32 and then find the general term for that. So we have 2, 8, 32, right? And that's our sequence. Well, let's see. If I take 8 minus 2, I get 6. 32 minus 8 gives me 24, I think. Yeah, it gives me 24. So really, if I look at the difference between them, I get 6 and I get 24, so this is not arithmetic, right? So let's try the geometric test. Well, the geometric test says take this term here, T3, and this term here, which is T2, and this term here, which is T1, and divide them, right? So I'm going to divide them. I'm going to say, okay, what is T3 divided by T2? Oh my word, what am I writing? T3 divided by T2 is 32 over 8, and that gives me 4. Oh, brilliant. What is T2 divided by T1? Well, T2 is 8 divided by T1, which is just 2, and the answer is 4. So clearly I can see that the constant ratio between them, even if you didn't know that 2 times 4 gives you 8, you can easily take 8 divided by 2 to give you that this must be multiplied by 4, and that over there must be multiplied by 4. At this point, you just write down the general term as Tn equals AR to the n minus 1, and you substitute in the values corresponding to that. Tn will equal to A. What is A? A for the sequence is equal to 2 because that's the first term, and R is equal to 4 because we calculated it and we could observe or do it by inspection. So we would say over here that I have 2, and you can write that one outside, it's fine, multiplied by 4 to the power of n minus 1. Now let us test the sequence. Remember, you must get 2, 8, and 32. Let's test it. 2, 8, and 32. And your sequence is Tn equals 2 times 4 to the n minus 1. We're going to test this formula over here. Okay, so let's take T1. Okay, so I'm going to pause over here because I didn't fully hit record again. But if we substitute in 2 times 4 to the 1 minus 1, I get 2 times 4 to the 0. And 4 to the 0 is just equal to 1. So I get 2 times 1, which gives me 2. If I substitute in 2, I say 2 times 4 to the power of 2 minus 1. 2 minus 1 is just 1, so that gives me 4 to the power of 1. And that's 2 times 4, which then gives me 8. If I do the last one, I can see clearly that I substitute in a 3 into the n, I get 3 minus 1 over there, which is 4 to the power of 2. And 4 to the power of 2 is 16. And then I say 16, this term over here, multiplied by 2, which is 32. And so clearly this formula works, right? So let's do it for the next one. And the next sequence that we have is a half, a quarter, and an eighth, right? A half, a quarter, and an eighth. So let's just put that down over there. I've got a half, I've got a quarter, and I've got 1/8. Now we clearly know what the constant ratio is, but we're not going to do it that way. We're going to actually calculate the constant ratio using the formula for it, right? So we can say A is equal to a half, and R is what I want to calculate over here. So I'm going to do that calculation over there. R is equal to T3 over T2, and T3 over T2 is 1/8, 1/8 divided by 1/4. So clearly you can see that an eighth multiplied by 4/1, you use the tip and times method, gives me 4/8, which is equal to 1/2. And similarly, I can do that for 1/4 divided by a half, which is equal to 1/4 multiplied by 2/1, tip and times once again, and that's going to give me the following, which is 2/4, which is 1/2. So clearly we have a constant ratio over here that says when you multiply by a half, you get this thing over here. Now very simply put, I'm just going to do the general formula. It's Tn equals A times R to the n minus 1. The A over here is going to be a half. The ratio over here is also a half, it happens to be. And the power there is going to be just n minus 1. So I'm not going to do the test to check whether this is correct. I'm going to leave that up to you. And then finally, I'm going to leave the sequence of 5, 10, and 20 for you to also do. Okay, so that's your general formula. Remember to test the formula, find the values of T1, T2, and T3 and see if they correspond. Okay, that's for you to do. Okay, the other one you must try is 5, 10, and 20. And so I'll give you a minute, pause the video, and then you can tell me what's the general formula. And once you've done that, I'll write down the answer for you. Okay, so brilliant. I guess you've done that. Don't cheat now. If you haven't, press pause again and go and do it. Try it, attempt it. It's Tn. A is clearly 5. The ratio is clearly 2 because you multiply by 2 over there and you multiply by 2 over there. And that's going to be n minus 1. And you can do the test again, T1, T2, T3. Okay, very good.